Number 7. Now, what we have to do is we have to talk about the conditions for this problem. When they talk about conditions, they are talking about random, normal, and independent. So I'm not going to read the question, but it was about this well water, and I think we've got a problem with random because they don't really talk anything about that. What they talk about is all of the babies on one side of town, 16 of them had birth defects. And all of the babies on the other side of town, 3 had birth defects. All of them. It's not a random sample. So that's going to be a problem. And then secondly, we're going to have an issue with normal as well, because remember, the number has to be bigger than 10. So if we look at this and we say 3 out of 228, if you take that decimal and multiply it by 228, what are you going to get? You're going to get 3. The successes and the failures, there have to be at least 10. Okay, this number has to be 10 or more, essentially. So, that's not going to work. That's the answer to that question. Let's go to the next one. Okay, let's look at number 9. Now, what we're going to have a problem with is the normal part again. So, one way to think about it is successes and failures. Both of those, successes have to be at least 10 and failures have to be at least 10. Let's think about that. So like this, all 12 shrubs resprouted. Well, that's great. We had 12 successes but 0 failures. That's not going to work for us because we have to have at least 10 in both groups, successes and failures. Let's look at the next one. 8 out of 12. So we've got 8 successes and 4 failures. Neither one of those is 10. Okay? If you did the proportion times the sample size, you would come out with the same numbers. So one way to think about it is successes and failures. 3 out of these 4 numbers are less than 10. Not going to work. Okay, number 11. We are going to do a confidence interval. 90%. Okay, we need 2 proportions. So 73 of the 158 and 26 of the 143. We're talking about younger people versus older people using instant messaging. So let's take a look at that. So for the younger people, this one, we get this proportion. And for the older people, I divided and I get that number. So here's that big formula for our confidence interval. So I'm just going to plug the numbers in, see what we get. Okay, so I plugged in all the numbers. Subtracting the 2 proportions, the 1.64, remember that critical value. So we put that into second vars, inverse norm, and we're going to put 0.95 for our confidence interval. And then I just plug in these numbers here. Don't forget, this is the sample size for our first group and our sample size for our second group. And then we crank this number out. But I'm just going to use the calculator. So remember, I press the button that says stat over the test, and it's all the way down to letter B, a 2 proportion Z interval. And they give me this interval of, it goes from 0.196 to 0.364, like that. So, what does this mean? We are 90% confident that the difference between the 2 proportions is somewhere between 19% and 36%. What does that mean? It means that we think that younger people between 19 and 36% more younger people use instant messaging than older people. That's the difference, okay? Higher number when we subtract them. Okay, hopefully that makes sense. Let's go to number 13. Okay, on this one, letter A, we are going to do a confidence interval, 99%. Okay, so we need two proportions. Let's see. 986 out of that group, right? And then for the men and for the women is 923 out of that group. Okay. So people that live with their parents. So here are our two proportions. I'm going to get the decimal representation and subtract them and do that big formula for the confidence interval. So here's all the stuff. Men minus women. And here's our critical value, inverse norm, for 0.995. And then this number minus 1 is right there. And this number minus 1 is right there. And here's our sample size, originally for men, and our sample size for the women. Okay, crank it all out and let's see what we get. So what does this mean? We are 99% confident that the true difference of proportions of men and women living at home is somewhere between 5% and 12%. What does it actually mean? Well, since it's a positive number, this number, the men, is bigger than this number, than the women. So we're thinking that more men than women are still living with their parents, somewhere between 5 and 12% more men than women live with their parents. Letter B. What does this tell us? Does your interval from part A give convincing evidence of difference between population proportions? Explain. Yes, it does. It tells us that there is a difference between them because 0 is not in our interval. 0 is not in there. It's not contained in the interval. So that tells us that the two proportions are going to be different. Okay, that's that.